The development of new electric vehicles requires innovative components. The rear axle carrier of this model generation is produced from a single aluminum casting, combining high strength with low weight, an essential factor for the efficiency and range of modern e-mobility. But before the component can be installed in a vehicle, it undergoes a highly precise production process. The process begins with the raw aluminum casting. In automated systems, the parts are first loaded into fixtures and transported to heat treatment. During the annealing process, the material achieves its required strength properties. Immediately afterward, quality assurance begins. The components are first inspected for cracks. For this, they are treated with a contrast medium, then dried and cleaned again after inspection. These tests are critical, as every single part must meet the strict standards of the automotive industry. At the same time, digital traceability ensures that every production step is documented. Camera systems verify codes and component identities, while measuring stations monitor dimensional accuracy with high precision. This creates a complete process record for each individual part. At the heart of the system is the core of manufacturing, mechanical machining. High dynamic machining centers perform milling, drilling, and thread cutting. 3 twin spindle machines handle the complex geometries with maximum precision. A 6-axis robot moving along a linear axis of around 20 meters connects the individual stations. It transports the components between deburring, machining, and cleaning, ensuring continuous operation of the entire line. After machining, the cast parts are deburred and cleaned before receiving their vehicle-specific components. In the second-to-last station, the rubber bushings are assembled. A robot positions the parts and presses in the bushings with force and displacement monitoring. This is followed by the end-of-line inspection. Only when all quality criteria are met are the rear axle carriers, each weighing around 25 kilograms, labeled, documented, and packed into transport racks. The entire system operates in a highly automated and digitally connected environment. Software solutions link machines, inspection systems, and ERP systems, capturing all process data. This ensures complete transparency across every step of production. For RUBIG, this combination of automation, precision, and digitalization is a key factor for competitiveness. This is how a high-precision chassis component is created from a raw aluminum casting, efficiently manufactured, fully documented, and ready for use in the next generation of electric vehicles.